Hello everyone, welcome back to my channel. My name is Piyush and this is video number 36 in the series CKA 2024. Because we'll be starting with a lot of troubleshooting scenarios after this. We'll be starting with application failures troubleshooting, control plane troubleshooting, worker nodes troubleshooting, and different cluster components and so on. So I wanted to cover this brief video about how logging and monitoring works in Kubernetes. So it's gonna be a short video with the basic concepts, and then using these concepts we'll be doing the further troubleshooting in the upcoming videos. So yeah, try to watch this video and see if it is helpful to you. I'm sure it will be. The comments and like target of this video is 150 likes and 100 comments in the next 24 hours. It's pretty simple, pretty straightforward. So without any further ado, let's start with the video. So if you remember the video in which we discussed auto scaling, VP, HP and so on, we discussed that Kubernetes does not comes with inbuilt monitoring, right? So we installed an add-on to the Kubernetes cluster which is called metric server, right? So this is one of the CNCF project. This is one of the add-on that we install on top of our cluster so that it could expose certain metrics for the monitoring and alerting tools. What are those metrics? These could be your memory utilization, CPU utilization, and so on. So here is the project over here in the GitHub repository. So we install it with the help of this YAML that they have provided, or you can install it via Helm chart as well. um, what you actually do, so you go to your terminal. I'm in my Kubernetes cluster. So if I do get nodes, I have 3 nodes running. So if I run kubectl apply on the metric server YAML, it will download and create the objects for us. So now if I do kget pods in the kube system namespace, I should see something called as metric server. Okay, it's getting up now. It should be. Let's do a watch on it. It would take maybe a few seconds or a couple of minutes to be up and running. And once this is up and running, and if we wait for few more seconds or few more minutes, it will start exposing the metrics. So how it will expose the metrics, I'll just keep it waiting while I'm explaining the concept. So how it works, we have your nodes, okay, over here on the right side. On each of the nodes there are certain agents running. Okay, some node level agents, which is kubelet. What it does, we have already discussed. Kubelet actually do the container management of that node. Let's say this is worker node 1. So kubelet is running on worker node 1. It will make sure that it will receive the request from API server and take the necessary action like restart the container whenever there is a need, stop and start the container, and so on, right? So it does the container management at node level, and it basically set up the communication between worker node and the control plane node. Okay, so now there is another daemon running on the node which is called C advisor. Okay, C advisor, it will collect the metrics and it will aggregate the metrics from container runtime. Okay, and it will then publish these metrics to kubelet. Okay, this is not C advisor does not do any operation on the metrics. It don't expose it, it don't forward it to anything. It just collects it from the container runtime, it aggregates it, and it sends to kubelet, because kubelet is the node agent which is responsible for interacting with the control plane node, right? So C advisor directly cannot do that. Only kubelet has authority to do it, right? And it also collects the pod data. Okay, once it gets all the metrics, it gets all the data like node level metrics and resource level metrics, like memory and CPU utilization of the node, as well as memory and CPU utilization of each of the pods and services running on the node. Once it gets all the data, it then sends it to metric server. So metric server is what we have installed now. Okay, and metric server then exposes those metrics, the metrics that we have received from kubelet. It exposes those metrics with the help of metrics API, and it will be then consumed by API server. So when we run any command, let's say kubectl top command, it fetches the metrics from the metrics API that was sent by metric server. Okay, so if we go back over here, so now it is I'm not sure if it is running now, but let's see. I see the pod is container is not ready. So let's have a look what is happening. kubectl describe pod, and then namespace is kube system. Okay, it says readiness prop fail with status code 500. Okay, so it's still not up. And let's see if we have an event. It says the pod itself is running, but somehow the readiness probe is getting failed. Okay, I don't see any event as well. Okay, let's try to run the command top node. No, it says metrics API not available. Okay, and if we do logs on it, kubectl logs when n equal to kube system failed to script the node, verify the certificate, failed prop, storage ready, no metrics to serve. Okay, I would have to troubleshoot this issue. And it has something to do with the compatibility of metric server with the Kubernetes version that I'm using. Okay, it does say that it supports, like it should support the latest version. I'm using 1.30, but maybe they have a separate YAML for it. Let's see. Um, uh, yeah, it has installed the latest YAML. And okay, it says kubelet certificate needs to be signed by cluster CS certificate authority or disabled by passing TLS to to metric server. Yeah, I guess this was one of the steps that we took while working on that auto scaling video. So let me pull up the document. Okay, so it was part of video number 16, not 17. So what actually we have to do, we have to pass this particular flag inside the container section of the pod, right? Because we have not installed the certificate signed by CA, so that is why. So now we have to disable the certificate validation. Now let's go back and let's do kubectl get deploy hyphen namespace is kube system. We have to edit the deployment itself. Okay, and it says metric server is up because I did made the changes. So let's do a kubectl edit on metric server. Actually, let me do a cleanup first. kubectl delete deploy metric server hyphen namespace equal to kube system. Okay, it's deleted now. Okay, now let's use that YAML again to install it, and then we'll make the changes. Okay. By the way, in the exam, this metric server will already be installed, so don't worry about it. So I've applied the YAML. Okay, and now let's do a get deploy. Now this should be again stuck in that state, and if you do a describe on it, kubectl describe deployment, you will see the event which says certificate validation failed, something like that. Okay, namespace is kube system. Okay, still coming up, still hasn't emitted the error, or you can check the pod as well. Get pod instead of get deployment. And here is a metric server pod. The container has not been started. So describe pod hyphen namespace equal to kube system. Okay, and it says healthy because props are getting failed. And if you scroll up, you will see it running, right? But the container itself is not running, and there is no argument that says TLS insecure certificate failed, right? And if I do instead of describe, if I do logs, then we'll see the error. It should be logs. I guess the pod itself. Okay, there is a different pod name. Let me copy the exact name from here. Okay, what is happening? kubectl. Okay, it should not be pod kubectl logs. I've misspelled the command. Okay, now it says failed to verify certificate, cannot validate certificate for this node because it does not contain IP sense node for worker 2. Okay, so we have the missing certificates for metric server, so that is why it is throwing the error. Now instead of logs, let's do an edit on this deployment kubectl edit deployment metric server over here, and we'll go to the container section, scroll down where they have specified the container arguments. Okay, I'm gonna press shift A to go to the end of the line, and in the insert mode I'll press enter, and over here I will add the argument which I can copy from here. So let's go down and over here. Okay, just copy this, go back, and I'll paste this. I've missed a dash over here. Okay, and that's it. Now I'm gonna save it and exit the VA editor. Now it says deployment has been edited. So if I do kubectl get deploy -n equal to kube system. Okay, still hasn't come up. So let's add a watch to it. Or maybe we can delete the pod so that it will recreate the pod. Let's do that. Get pod -n equal to kube system. Okay, it has created a new pod already, so it will terminate the older one once this is up. So let's wait for it. Okay, now this is up. Okay, and now we have to wait for some time before it starts exposing the metrics. So let's try it if it does. kubectl top pods or top nodes. No, not yet. So we'll wait for some time. Okay, anyways. So this is how you set up metric server, and this is how you do basic troubleshooting. Like the commands that we use kubectl describe on the pod to check the events. We check the logs with kubectl logs, and if there were multiple containers inside the pod, we can add the container name as well in front of the command kubectl logs, then pod name, that container name, and so on, right? So this is how we actually check the logs, and these logs are nothing but something. So if I run the get pods and let's say I'll copy this kubectl logs on this pod, okay, and namespace is kube system. So these logs are nothing but the logs that has been emitted to the std out or std error, right? Now it's not been stored outside somewhere, it's just stored locally, and we have not transferred it to a third party system for log aggregation and so on, right? So that is why I'm saying Kubernetes comes with the limited capabilities of monitoring and logging. Now as part of a kube admin or as part of a DevOps engineer, your job will be to transport this log to a third party system such as Splunk, such as um, there are many more systems that you can use, third party applications, some open source tools, or some vendor specific tools, open source tools such as elk. So using that you can transport these logs to those applications, and then you can run some aggregations, you can create some charts out of it, you can create some log based alerts and so on. So you can run some business analytics and some advanced observability with the help of these logs. Okay, so that's about logs in Kubernetes. And for monitoring, we have already seen a metric server. So metric server should start emitting. No, not yet. Okay. So we have already seen this in video 17, right? Where we expose these metrics for HPA, VPA, and you can check that. Now, as part of this video, this is what we wanted to cover. And let me see if I have missed anything else. Okay, so the other thing that I wanted to cover is how do we actually do the troubleshooting in Kubernetes cluster when Docker is not available. So let's say this is your Kubernetes cluster. This is running on 1.30. And if you remember correctly, in one of the previous video, I've mentioned that from Kubernetes version 1.24 and above, the default container runtime has been changed from Docker. Earlier, it used to be Docker. Now it has been changed from Docker to container D. So now, like when we were interacting with Docker, what we were using, so let's say we have a Docker host over here. So when we were interacting with Docker, we were using a Docker client, which is with the help of these commands like docker ps, docker ps-a, and so on, right? So we were using Docker client to interact with the Docker runtime or the Docker based container runtime. Now, with Kubernetes version, if you run docker ps, you won't see it installed because this does not comes with the Docker installation. And because we are using container D instead of Docker, there is a separate client for that. So that client is called CRI-CTL. So we will be using this client for the troubleshooting in the Kubernetes cluster instead of Docker commands. So if you press this, you will see different options that we have available for that. So it's basically similar to how Docker client work, only a few exceptions. So for example, if we wanted to check the running processes, with Docker, we were using Docker PS. So with CRI-CTL, we will use CRI-CTL PS. Okay. Currently, it's throwing me error for permission denied. Let's provide the permission to this file. Chmod 777. Okay, let's run it again. Okay, right. So CRI-CTL PS to see all the running containers or the running pods. Now to see the exit pods, CRI-CTL PS-A, which is same as Docker, like how we were using the Docker commands. Now you don't have to worry about it because for the installation of it, because it's already comes with the Kubernetes installation, so you don't have to install this manually. Just like kubectl, if you have used the Kubernetes installation with kubeadm, kubectl will be there as part of those installation steps. So CRI-CTL will be there because it's the container runtime. When we install container runtime, this utility by default got installed. Now to troubleshoot the issue, the application failure, like why do we use docker ps when we have kubectl commands, right? So let's say your API server itself is not responding. If your API server is not working, that means your kubectl commands won't work. Okay, so let's take an example. So if I go to at etc kubernetes manifest, okay, and if I move the API server YAML from here, because it's a static pod, if I move the YAML from here to another directory, that would make API server becomes unavailable because the pod of API server will be crashed. So sudo move, let's do that. And now if I run kubectl get nodes or any kubectl command, I will get the error something like this. Like the connection to the server was refused because the API server listening on this particular IP on this particular port is not available now, right? So in that case, when kubectl command itself is not working, when your API server itself is not responding, how would you troubleshoot the cluster? We troubleshoot the cluster at the container level. Now we know that kube API server is nothing but a pod. Even though it's a static pod, it's a pod running on the cluster, right? So we should be able to view with the help of docker ps commands in case we were using Docker runtime. Now that we are using container D, so we can do CRI-CTL PS and then we can grep API server. Okay, it's not running, we can see that, right? So if I do CRI-CTL PS, we see kube scheduler master, kube controller, CSI node driver, core DNS, Calico, kube proxy, HCD master. All the control plane components are running except API server. So we know there is something wrong with the API server. Okay, so what we'll do is we'll go to that directory and we'll see that API server YAML is missing over here, or there is some issues with the YAML. We can open it and check for the errors, right? There is some issue with the error or it is missing. Now what we'll do is if we know it is missing, we just move it back from where it is, say kube API server YAML to this directory, and okay, operations not permitted. So let's do a sudo on this. Okay, as soon as we do that, and as soon as we run the CRICTL PS command again, we see API server is available over here now, right? So let's run that grep command as well. Okay, we see the API server master is running again. So now we can run our kubectl commands. So that is why CRI/CTL commands are important to understand from the troubleshooting point of view. And there are many other cases where you won't be using kubectl command and use CRI/CTL command directly. Let's say you are facing an issue where you are not able to, your containers itself are not able to pull the image from a registry. In that case, what you will do, you will try to manually pull the image with the help of CRI/CTL utility. So CRI/CTL pull nginx, let's say this command. And then you see like whether your node has networking issues or your container itself has some other issues, right? It says no image is up to date, so no issues with pulling the image. Let's pull another image. Look, Redis. So we are able to pull the image, right? Because it says it matches the local image with the remote image, and it says we don't have any issues. It is up to date basically, right? So this is working fine. Now, if you want to check the logs, so let's say kubectl get pods, what pods we have running. So if you want to check the logs of this particular pod, we can use CRI/CTL logs and this. Okay, there might be some issues with the command. Let me see. Okay, let's go back to the documentation, and CRICTL would be inside the debugging. Debugging with CRICTL, I guess this one. Okay, so here you can list all the pods, CRICTL pods instead of kubectl pods, and list by label, list images like you do Docker images, you can do CRI/CTL images. So as I said, it works similarly the Docker, but there is some changes. For example, to run a container, right? We used to run Docker run and the command. With CRI/CTL, we have to first create a JSON, right? With all the details like name of the container, namespace, log directory, and so on. And then you run the CRI/CTL run command, run p command with the JSON file to start the container, right? And let's say even if you are pulling the image, like what we did, you have to create this config YAML, sorry, config JSON for pod, for container, and then you can run CRI/CTL create with the ID. Okay. Now, what I was, okay. So I guess you cannot check logs. Okay, let me see if it's there over here. So CRI/CTL logs hyphen help. Okay. Fetch the logs of a container. Okay, so it does not fetch the logs at the pod level, it fetch at the container level, which is same as in Docker, right? So what we can do is CRI/CTL get pods. Okay, no, not get pods, CRI/CTL PS. Okay, and let's say this is the container ID. So CRI/CTL logs and then the container ID. Okay, it says permission denied because we are fetching the logs of Kube API server, which is stored in a directory that our CRI/CTL does not have permission to. So let's run a sudo along with it. Okay, now we are able to get the logs. To tail the logs, we can just add CRI/CTL logs hyphen F, like the way we do in Docker logs command. Okay, and then it will tail the logs. You see over here at the last line, it is showing the logs in the real time as it is progressing further. Okay, so yeah, CRI/CTL debugging with CRI/CTL is really important, and I will also share the link of this document. For sure, there's gonna be a task in the exam which says how to, yeah, like you'll be given a task to debug the node or to debug the application with the help of CRI/CTL. They can mention to use CRI/CTL or they won't mention it, right? So you see if Docker is not installed, which in most case it won't be, so you have to use CRI/CTL utility for that. Okay, so that's what we wanted to cover in this video. For the next video, we'll be looking into application failure. I will provide you a sample application, a sample 3-tier application with multiple services, with multiple deployments and pods, and we'll see how we can troubleshoot if there is an application failure, right? So there are different aspects of it. So we have already seen how do we get the logs, how do we do a describe on it, how do we tail the logs, and basically the CRI CTL commands that we use for debugging. Now we'll see it from the application failure perspective in the next video. So thank you so much for watching this video. I'm sure this was helpful. If it was, please try to complete the comment and like target for this video, and don't forget to share the series with your friends and colleagues who could take the benefit of this learning opportunity. So thank you so much for watching. I will see you soon with the next video.